everyone! So for today, we'll be working on the solution for population growth, which is part of labs in week 1 of CS50 by Harvard. So for this exercise, we are tasked to get more information about the llama population. So in this case, we let x equals to the llama population, and we are told that the number of new llamas born each year is found by taking x divided by 3, right? And on the other hand, the number of llamas that die each year is taken by x divided by 4. Okay, so what does this mean? So for example, if the llama population x equals to 1,200, this means that the number of new llamas born every year is taken by x divided by 3. So it is 1,200 divided by 3, which will give you 400. Likewise, the number of llamas that decline every year would be taken to be 1,200 divided by 4 equals to 300. So what is the llama population at the end of the year? It would be x plus 400 minus 300 equals to 1,300. So that would be the total number of llamas that you have at the end of the year. Okay, so what is the objective that we need to achieve in this case? So firstly, the user will key in the starting population size and we will use x to represent that. So the starting population size must be greater than 8. Okay. Secondly, they say that the user must key in the ending population size, and let's use y to represent that. So the condition is that the input must be greater than the starting population size. So this means that my ending population size must be greater than the starting population size that you key in earlier on. So what the program must do is that it will calculate the number of years required for the starting population size to reach the ending population size and print the output. So what this means is that you know that with every year, the number of llamas will increase, but how many years will it take for the number of llamas to actually reach your desired ending population? So that is what your program must print. So likewise, in this case, you will take the number of years to be represented by n. So now we can see that we've actually come up with the logical sequence of what we want to input into our program to kickstart the whole thing. So let's formulate the code now for this segment that we have. So to start, we need to copy the distribution code, which is the starter code that CS50 Labs has actually provided. So if you can see here, this is what the headers will include, which would be, include CS50, include standard IO, and the usual headers like int main void. And as you can see, we have 4 things on our to-do list to cover. So for this first portion, let's cover the first 2, which is to prompt for the start size and to prompt for the end size. Right, so to prompt for the start size, can you see that number 1, the user will be prompted to key in the starting population and it must be an integer greater than 8. So what this means is that we need a validation rule in place where the system will keep prompting you to key in the starting population as long as the user keys in a number that is less than 9. The system will reject it and keep prompting for you to re-enter a correct starting population. So can you see that we have a loop that's forming here, where we start by asking the user for the starting population size. The system should check, is the input more than 8? If yes, okay, the code will continue running. If no, it should loop you back to the start to ask you for the starting population size again. Okay, so that is what we first need to prepare. Next, the user will also be prompted to key in the ending population, which we will use y to represent it. So again, there are some checks in place, which is firstly, y must be an integer, and secondly, it must be greater than your starting population. So likewise, there will be another validation rule to check the input, and the system will keep prompting you for an ending population if you key in a number that is less than your starting population. Likewise, you can see that we have another loop here, where you will ask the user for the ending population size, and if it is greater than the starting population that you key in earlier, the code will move on to the next step. But if you key in an ending population that is less than the starting population, the program will bring you back to the start again and ask you to key in for the ending population. Okay, so let's hop on back into code for this. Okay, so number 1, what we should do is that we should get the starting population. So let me just write the comment here so that we know what this segment is for. Okay, so like we mentioned, we're using x to represent the starting population. So I'm going to just say that I have an integer that I will label as x. Okay, and to get the loop that we actually talked about, we will be using a do-while loop. So what does this mean? This is what we want the system to do as long as the condition is not met. Okay, so number 1 we do, then we open curly bracket, x, which is your starting population, equals to get int, which means that we're trying to get an integer from the user, where we will prompt them for the starting population. Okay, and we will keep asking the user for the starting population as long as x is less than 9. So keep doing this while x is less than 9. Okay, next let's move on to get our ending population. So likewise, we're going to tell the system that it's going to be an integer called y, right? And now we'll do another do while loop. So what do we want the system to do? We want it to get y, which is an integer, and we will ask the user for the ending population. Okay, and it will keep asking the user for the ending population as long as the ending population key in is less than the starting population. Okay, so now let's move on to the second part of the program. So now what we need to do is we need to calculate the number of years that it will take for your starting population, which you key in, to reach your desired ending population. So essentially, what you have told the system is that if you start with X number of llamas, how many years will it take for you to reach Y number of llamas? Okay? So for any given year, so what you saw for what we formulated earlier on is that your ending population becomes the starting population of the next year. So let's say in year 1, you actually have 1,200 llamas. At the end of year 1, you will have 1,300 llamas. So what does this mean? In year 2, the starting population of your llamas would be 1,300. So on and so forth. So the starting population of each year will be taken to be x plus x divided by 3, which is the number of llamas born every year, minus x divided by 4, which is the number of llamas that die every year. Okay, so we're going to write down what we want the system to do in equations first before we move it into code. Okay, so I have a table here which will show the year and the population at the end of that year. Okay, so let's say in year 1, what you have is that your ending population at the end of year 1 would be the starting population of year 1, which I put as x with a subscript 1, plus x divided by 3 minus x divided by 4. Okay, so the system will check, is your ending population equals to y, which is what you have keyed in? If not, the system will go on. Okay, let's say 1 more year passes. So your new ending population will now be the starting population of year 2 plus the starting population of year 2 divided by 3 minus the population divided by 4. The system will ask, is the ending population now equals to y? Okay, if it doesn't, okay, let's go one more time. So at the end of year 3, your ending population would be x plus x divided by 3 minus x divided by 4. So does it reach y, which is what you have keyed in? No? Okay, in 1 more year. Okay, so on and so forth. So the system will keep printing each year and check the ending population every time. And as long as your ending population for that year does not equals to y, the system will keep printing. So can you see now, based on the equation that I have for each year, I can actually see a pattern where for the year that we are looking for, the ending population will just equals to x plus x divided by 3 minus x divided by 4. And then once we reach the desired ending population, the program should stop running when the ending population finally reaches y and print the number of years. Okay? So now, how do we formulate our code? What we have done is that we have defined how to get the starting population and we have defined how to get the ending population. So now what we want to do is that we want to tell the system when and how to print the number of years. Okay? So some of the things to take note of is that years must be an integer and we're going to start counting from year 0. So just remember, we're looking for the number of years it will take to reach the ending population. So the program will start from years equals to 0 and it will keep running as long as your starting population is less than the ending population. Okay, so if starting population is less than ending population, the equation will continue to run. So when the system finally reaches the threshold where the ending population reaches what you have keyed in, the system will stop and print the number of years. So now let's move on to our CS50 IDE environment. So now I'm just going to move on to the next section where I will put a comment here. This section will be defining what is the number of years needed to reach the ending population. Okay, So what I'm going to tell the system is that, okay, the system can soon expect an integer that I'll label as years, and it will start from 0. Okay, so I've just told the system what years is. So now I'll just label my next section where this will update the population until the stipulated ending population size is reached. Okay, so I'm just going to do a while loop. So as long as your starting population is still less than your ending population, I'm going to keep running the program. Okay, so I'm going to put this in curly bracket where x equals to x plus x divided by 3 minus x divided by 4, which is the formula that we have to determine the number of llamas at the end of every year, right? And the system will keep running for every incremental year. So that will be represented by the number of years you have plus plus. So what this means is that this system will keep running in increments of 1 year. Okay? Now what I want the system to do is to print the number of years. So we can do that by writing printf years and for integer \n, comma years. So what this means is that we're going to tell the system that it will print an integer, and this integer will be the years that you have found just in the earlier section. Okay? Okay, so now let's test this out. So I'm going to make population ./population. Okay, so now you can see the system's asking for a start size. So let's say I'm going to try that start size is 8. Okay, very good. It shows that the system rejected it. So now I'm going to just move on to the test that the labs have mentioned to do. So if your starting size is 1200 and your ending size is 1300, how many years will it take for the starting population to reach the ending population? Okay, 1, and that is correct. Let's try again using the sample that the labs has given. Start size equals to -5. Very good, the system rejected the input. Okay, let's try 3. Okay, very good, it rejected it. Let's try 9. Very good, so you can see that the input was accepted. That's why now it goes on to ask you what is the end size. So let's try 5. Okay, so you see it got rejected because your starting size must be smaller than your ending size. Okay, let's try 18. And there you go, the number of years it takes is 8. So let's try again very quickly. If your start size is 20 and your end size is 100, it takes 20 years. And now if your starting size is 100 and your ending size is 1 million, it takes 115 years. And yep, there you go. This is a solution for population. So if you found this video helpful, please remember to like and subscribe. This helps the algorithm. And also maybe for those who are looking for similar walkthrough solutions through this program, they will find this video to be helpful as well. And by subscribing or putting a like, this actually helps indicate to people that this video was actually useful, and maybe they will like this video too. Thank you so much.